Hello everyone, welcome to my channel. So today's our leetcode daily challenge problem is magic squares in grid. Okay. So what does the question state? A 3 cross 3 magic squared is a 3 cross 3 grid filled with distinct numbers from 1 to n, such that each row and column and both diagonals all have the same sum. So basically we are given an array, right? We are given row and columns, right? Grid of integer. uh, uh, you can see here it's a vector, right? And you have to count how many 3 cross 3 continuous magic square subgrids are there, right? So basically, what is a square grid? Suppose if this is our magic grid, then the sum of all the rows, right? Basically, the first row, second row, and third row, first column, second column, and third column, and the diagonal elements are same. Okay. So basically, in this case, you can see here this is our first 3 cross 3 grid and this is our second 3 cross 3 grid, right? Like first one is this one and the second one is this one. Now, if we check this is a magical grid or not, 9 plus 4 plus 2. 9 plus 2 is equal to 11 plus 4 15, right? 7 plus 3 10 plus 5 15. 8 plus 1 9 plus 6 15, right? 8 plus 3 is equal to 11 plus 4 15. 9 plus 1 10 plus 5 15. 7 plus 9 plus 6 15. And if we check diagonals here, 8 plus 2 plus 5 is equal to 15 and 6 plus 4 10 plus 5 is equal to 15, right? So basically everything sums up to 15, right? So this is our magical square. Okay, now we will check the second square. As you can see in the first column, 5 plus 3 is 8 plus 5 15, right? Second one is 8 plus 1 plus 6, that's equal to 15. 9 plus 2 plus 4, that's also 15. Okay, and if we check the diagonal, 7 plus 1 plus 4 is equal to 12. 3 plus 1 plus 4 plus 2 is equal to 6. So it is not equal, basically, right? Diagonals are not equal, so this is not our magical uh, square. Here in this example, this is not a 3 cross 3 grid, right? So we will not consider it as a magical square. So now what we can do to solve this particular problem? See here, I have basically first taken the number of rows and columns of this particular grid. So total m knows the rows and n knows the columns, right? And initially count, like we have to count the magical squares. So that's why I have taken count, which is equal to 0 for now. Now what I will do, I will traverse through this particular grid. Okay. So I is equal to 0, I is less than m dot 3, right? I minus 3. So basically here I minus 3 would be this only, right? Because I is 0 and 3 minus 0, uh, sorry, I m is 3, right? And 3 minus 3 would be 0 only. So I will be here only. I will not traverse any further row. And here, if we right, and if we see for j is equal to 0, j is less than n minus 3, n is 4, 4 minus 3 would be 1, and j plus plus. So basically, we will check here and we will check here. So what I will do is I will send this particular element to the fun, right? Fun function. Okay. So basically, I have sent the first index. Now what I will do, I will check for all this grid. Okay. So how can I do it? I will simply traverse from row is equal to I, right? Rho is equal to I, that is rho is equal to 0, and I plus 3. Till here I have to check, and till here row wise and till here in column wise, right? That's why here also I am traversing my grid to m minus 3 times. Okay, hope you have understood. So basically, I will traverse this particular whole grid. Okay, and I will check whether our integer is greater than 0 and less than 10. That is, all the numbers must be between 1 to 9 because it was given earlier, right? The strict number from 1 to 9 only exists, and it is also given that it must be distinct. Okay, so if the numbers are same, then we will simply return 0. Okay, and I have taken one vector of v of 10 size, and initially I have put all the zeros in here. Okay, why I have done this? Because we have to check all the distinct elements, right? So whenever I check any particular, whenever any enter we traverse through any element, if this conditions satisfies, then I will push on that particular values of grade is equal to 1. Okay, so v of row of column in this case is 4. Okay, so v of 4 is equal to 1, then v of 3 is equal to 1, then v of 8, right? So 1 2 3 4 5 6 7 8 9, right? So if it satisfies the magical condition grid, then it must contain all the elements from 1 to 9. Okay, that's why. At the end, what I will do, I will simply traverse through this vector and check if from 1 to 9 all the indexes are index value is 1 or not. If not, then I will simply return 0. Okay. And here else condition denotes if the value is 0 or greater than 9, then we will simply return 0. Okay. Now, what I have done here, I have taken the sum of row 1, that is this, right? So I suppose I is 0 here. Okay. So I is 0 and 0 0 index, 0 plus 1 index, 0 plus 2 index, that is 0 0 0 0 plus 1, 0 plus 2, right? For row 2 I have taken I plus 1 and the same, so I plus 1 would denote this row and 0 1 2 will denote j, right? Similarly, I have taken this for row 3 and here I have taken for those columns. Okay, and for diagonals ij, I plus 1 and j plus 1 and I plus 2 and j plus 2 for this diagonal. Okay, and I and j plus 2, I is 0 and j plus 2 would be 2, then I plus 1 and j plus 1, yes, this one, and I plus 2, that is third row, and j is equal to 0, right? This. Now what I will check the condition whether all the rows and columns and diagonals are equal or not, right? Here I have written this condition for the checking that particular value. Okay, now what I will do, so if this condition satisfies, then what I have to do, I have to check whether all the elements are distinct and the values are from 1 to 9 or not. Okay, sorry, from 1 to 9 all the elements are filled or not. So I will traverse this particular vector which I have taken earlier, right? And I will check whether all the elements are 0 or not. If not, then I will simply return 0, else I will return 1 here. And if this particular condition do not satisfy, that is row and columns are not equal, then yeah, it will come and it will simply return 0. Okay, so if I run it, yeah, if it is running fine, and if I submit it, yes, it is accepted. So hope you have understood the problem, guys. If you like this video, give me a thumbs up and subscribe to the channel. See you in the next video. Till then, goodbye.